All right, so let's talk about 7.5 day 1 exponential and logarithmic equations. So we're going to be starting to solve these. I know we've done a little bit, but I'm going to they're going to get a little bit harder and kind of do some different stuff that you haven't quite done yet. So it's going to be a lot of fun. Okay, so the first ones are solving exponential equations with a common base. So this by far is the easiest because you can get them to be the same base. We've already kind of done a few of these, but I'm going to do a few more just to kind of refresh your memory. Okay, so it looks like I have 3 to the 2x equals 27. Can I rewrite these as the same base? And the answer is yes. You can rewrite this as 3 to the 2x equals 3 to the third power, right? Because 27 is 3 to the third. Okay, so now that your bases are the same, you set the exponents equal to each other, divide, and you get x is 3/2, right? We've done these ones a few times. Okay, let's do another one. Another one that's pretty straightforward and easy. 4 to the 3x equals 64. So it looks like 64, I can rewrite it as base 4. That would be 4 to the third power, right? So now that the bases are the same, you set the exponents equal to each other and divide by 3, so x is 1. Easy. Okay, this one is a little bit harder, okay? So I've got this it's being raised to this binomial. Don't freak out, it's not going to be that much different. Can I write these numbers as the same base? The answer is yes. 3 to the third power is 27, but 3 to the fourth power is 81, just in case you didn't know. All right, they are the same base, so now set those exponents equal to each other. So subtract 2, oh, that's a positive 2, and divide, so x is -1. Not too bad, right? Last one, if you want to pause the video, try this one on your own. Well, maybe not. Okay, so we've got 2 to the 3x equals 4 to the 2x, or 4 to the x plus 1. So this is still going to be the same. I'm going to have to rewrite this as 2 to the second power would give me 4. But usually I would do 2 times x, but now since it's a binomial, you're going to need to distribute. So it'll be 2 times x plus 1. Okay, the bases are the same. Set them equal to each other. Go ahead and distribute. I'm going to get my x's over on one side, so I'm going to subtract 2x, and I get x is 2. Not that hard, just a little bit further than what we've done in the past. Now, this is something that's new. For some ridiculous reason, they want us to round in the book to the nearest 10,000th. That's not really a common place to round. Just to give you a heads up, that's 4 decimal places. Okay, so we're going to do the same thing on this. Okay, so we've got 4 to the x equals 19. So can I get 19 to be in base 4? The answer is no. So we can't get to the same base. Okay, so since we can't get to the same base, we are going to do something that's totally new. We are going to take the log of both sides. Okay, so you'll see why it's going to be kind of cool because you're going to get to apply some of the properties you've learned. But trust me on this. So you're going to write the log of 4 to the x equals the log of 19. Okay, so now any ideas on how to get the x by itself? Well, do you remember that power property on logs? Whenever you have a power, you can move it out front for logs. So this will be x times the log of 4 equals the log of 19. Oh, now we're getting somewhere. So now since it's x times the log of 4, Let's go ahead and divide both sides by the log of 4 to get the x by itself. Okay, so x is going to be approximately, and you're going to have to use your calculator, and you're going to type all of that into your calculator. So log of 19 divided by log of 4. And you get approximately 2.1240. Kind of cool, right? Using those properties to solve. Okay, this one, let's see, what would you do first? I would subtract 8 from both sides. So 10 to the x equals 1,000, right? Okay, on this one, you could write these. Let's do the same base, change to the same base on this. And then I'm also going to do it the other way and show you that it works. So change to the same base. So this would be 10 to the x equals, how can you write 1,000 in base 10? Well, that's just going to be 10 to the third. All right, so then you set the exponents equal to each other. X is 3. All right, let's use show the long way. So show long way works. Okay, so I'm gonna start kind of at this first line right here, or the second line technically. So that line right there, and I'm gonna take the log of both sides. So the log of 10 to the x equals the log of 1,000. Move that x out front just like we did the last one. So I have x times the log of 10 equals the log of 1,000. Divide both sides by the log of 10. Stick it in your calculator, and so log of 1,000 divided by the log of 10, and x equals 3. Kind of cool, right? That it works both ways. Okay, 2 more of these. So, oh, that's kind of random. I have some random graphs in there. That's fine. Okay, so on this one, log of 12 to the y minus 2 equals 20. Can I write those as the same base? No, right? You can't do it. So now let's take the log of both sides. So the log of 12 to the y minus 2 equals the log of 20. Bring your exponent, and yes, it's a binomial, that's fine, we'll be all right, out front. So this is going to be in parentheses since it's a binomial. Y minus 2 log of 12 equals the log of 20. Okay, what do you think I would do next? Well, I'm going to try to get that y by itself. So the next step would be to do the log, divide both sides by the log of 12. Okay, so those cancel, which is what I wanted. And now I have y minus 2 equals the log of 20 over the log of 12. If I left those parentheses around there, are they doing anything for me? The answer is no. There's no number being distributed in. That binomial is not being raised to a power, so then I can get rid of the parentheses because they're not doing anything. Okay, now so let's add 2 to both sides. So now y equals the log of 20 over the log of 12 plus 2. And you're just going to type that straight up in your calculator. Be careful about your plus 2. Make sure that it's out to the side and it doesn't end up in your denominator, because then you'll get the wrong answer. Then let's go ahead and round this to 4 decimal places, because that's what the book wants. So y is approximately 3.2056. And one note is some people might be tempted to put this in your calculator, say at this point, and get an answer there. Let's wait till the end to put in calculator. And that means, and the reason why, you'll get close if you went the other way, if you rounded earlier, and you might actually get the same answer, but the most accurate answer every single time is to always wait till the very end to put it in your calculator and then round at the end. Okay, last one of these. It's the same type of problem. If you want, pause the video, see if you can do it by yourself. It's a little different, but overall, I bet you might get it. Okay, so I can't change these to the same base, so I'm just going to take the log of both sides. Log of 25 to the 2x plus 1 equals the log of 144. Move your binomial exponent out to the front. So now I have, in parentheses, because it's a binomial, 2x plus 1 times the log of 25 equals the log of 144. Divide both sides by the log of 25, just like we did on the last problem. You have 2x plus 1 equals log of 144 over the log of 25. Okay, so now this is a little different, but you'll be all right. So what would you do to solve for x? Well, the first thing you would do is subtract 1, right? So I would have, and that would minus 1, that would cancel. Then what would you do? Well, then you would divide everything by 2. So this is going to be x will equal, and this is how I want you to type in your calculator. You're going to have the log of 144 over the log of 25 minus 1. And now all of that needs to be in your numerator. Okay, so you're going to have a fraction within your fraction. You're going to be fine. Don't worry. It'll be okay. And so we need to divide all of that by 2. Okay, so now when you type all that in your calculator, and please make sure you're typing in your calculator to practice, x is approximately 0.2720. Okay, so these are pretty fun. So the next one, I wish I could get Desmos and I could screen share and all that, but I'm not smart enough to do that yet. So here's how you solve this by graphing. So the book has a couple problems like this, so that's why I'm going to just show you how to do it. On your test and your quiz, you won't have any like this, but it's good for you to know, just for future reference too. If you are taking the ACT maybe and you have access to a graphing calculator, there is a way to do this. So how you do it is you graph each one individually. So you graph y equals 5 to the 3x and y equals 500. Okay? And so your solution, it's going to be a cool kind of graph. You'll see it. You might have, if you're on Desmos, you're going to have to zoom way out, or your graphing calculator. It's kind of a pain because this is a horizontal line at 500, so it's going to be way up there. So the answer to this, so the x-coordinate of where they intersect is your answer. And I'm glad the book gave you this type of problem so you kind of get some more exposure to your just graphing these. And Desmos only goes 3 decimal places, so we can't round to the ridiculous 10,000th. We're going to have to do 3. Maybe if you're graphing on a TI or something, maybe it might. But this one would be approximately 1.287. Okay? And no, you're not going to have a graphing calculator to solve these problems like up above, which would be kind of cool if you could. But all right, so next one, same thing. You're going to graph y equals 6 to the x, and then y equals 4,565. And you're going to have to zoom or scroll way up because that's a horizontal line at 4,500, right? So when you do that, the x-coordinate is approximately 4.703. All right, last but certainly not least, everybody's favorites, natural logs. Okay, don't freak out. You'll be all right. So, do you have any idea of how to get the x by itself? What on earth would cancel out a natural log? you have any idea, think back into our previous homeworks, what would cancel out a natural log? And the answer is the famous e. So e, and remember e is like you raise it to a power, it's always e to the something power. So if you write this e to the natural log of x, these two, natural log and e, will end up canceling each other out and you are left with just x. But what you do to one side, you must do to the other. So this will be e to the second power, right? Because you have to you're raising both sides, e to the whatever is there. So this is going to be, and you're going to type that in your calculator, e to the second power, and it gives you approximately 7.389. Okay, not too bad. Just remember, e's and natural logs cancel each other out. So you want that if you're ever trying to get rid of a natural log, and it's going to come around in pre-calc, definitely calculus. You're going to see this stuff again, so it's okay. Don't freak out. Okay. All right. So first we've got natural log of 2x plus natural log of 3 equals 2. We've got two terms with natural log. I don't want two terms. I want one term. Okay. So how can I combine those? Of course, right? What do you do whenever you're adding natural logs? Well, you multiply those numbers. So that becomes the natural log of 2x times 3, which is just the natural log of 6x, right? Not too bad, okay? Now, it kind of looks like the last problem. I'm ready to raise it to the e, or I said that backwards, but you know what I meant. E to the natural log of 6x equals e to the, 2, e squared. All right, those cancel, and you're left with 6x equals, I'm going to wait to put it in my calculator because I'm not done, e to the second. What do you think I do next? Divide by 6. So x, you can type that all in your calculator, is approximately 1.232. Okay, so last one. Natural log, what in the world? We got a lot going on. Natural log of 3 parentheses 3x plus 5 squared equals 4. Okay. First thing some people might be tempted to do the square root, right? I get it. I would be tempted to, but don't, because it's going to be gross with that natural log. Don't do that. Okay? So let's do the e thing first. So I'm going to do e to the natural log of 3x plus 5 squared. Don't forget your square. Don't leave it off. Equals e to the 4. Those cancel, right? So now I have 3x plus 5 quantity squared equals e to the 4th. Okay, here we go. What do you think I would do next? Well, you could FOIL that binomial out. That would be kind of gross. And then you would still kind of be stuck because we have a binomial, we have e's. Let's do this instead. Let's square root both sides. Okay. So that would give me 3x plus 5 over here. Think. It's a square root, so we're going to have plus or minus. Do not forget that part. Okay, so what would the square root of e to the 4th be? Well, think of it was like the square root of x to the 4th. That would just be x squared, right? Well, this is the same thing. It's going to be plus or minus e squared. Yes, I know this is weird. The whole unit's weird. Okay, we got that done. Let's keep solving. So I'm going to minus 5. So I have 3x equals, do not forget your plus or minus, e to the second minus 5. Then divide everything by 3. So x is going to equal plus or minus e squared minus 5 all over 3. Okay, so you're going to be rolling your eyes at me. So whenever you do this, so to do the positive version of e and the negative version of e. Okay, so you're going to have, are you ready? So you're going to get the positive version, I believe, is x is approximately 0.796. And the other one is approximately negative 4.130. Okay. Are we done? You're going to be mad. The answer is no. We get to check for extraneous because we have a plus or minus. Or no, because we did this step right here, sorry. Because we did the square root function, which gave us our plus or minus. So check for extraneous solutions and draw a smiley face because you're happy about it, right? Okay, so I'm going to check that 0.796. And so we're going to plug it in. So I'm going to have this is me checking. So check. Plugging it into the very original equation. So the natural log of 3 times, and then we're going to check 0.796 plus 5, close parentheses, squared. All of that should equal 4. Okay? So now you will get 3.955 equals 4. Okay, is this a solution? The answer on this is yes. The reason why it's not 100% accurate is because we had to round, and so that's not an exact answer, but it is an approximation. So 3.955 is close enough to 4 that it works. Okay, let's check the other one. So the natural log of 3 times, this time we're going to do negative 4.130 plus 5 quantity squared should equal 4. Okay, so whenever I was working this out on my key before I gave you guys these notes, Desmos didn't like it when I typed this one in. So it was just acting crazy. So what I did is just did this part, I should actually draw that line a little bit further. Just did this part with the square, and I rounded because it was being funky. It may work for you, hopefully it does. And so all of that stuff in the parentheses squared gives me the natural log, and I went a few decimal places with it, the natural log of 54.6121. Okay, and let's see if that equals 4. Whenever you take the natural log of that, it's 4.002. So of course that one works too because it's close enough. All right, I know this was kind of a long lesson. I hope you enjoyed it. Have fun doing the homework. Let me know if you have questions. Have a great rest of your day.